My name is Richard Levy. I'm a professor of urban planning here at the University of Calgary, and I'm going to be talking today to you about computer modeling working in a digital world. And in this presentation, I'm going to talk a little bit about the history of architectural representation. I'm going to look at recent developments in design software. I'm going to look at the implications of that new design technology for both architects, urban designers, and designers in general. And I'm also going to look at the issue of the design of our cities when we start using all this new technology. Part of this presentation will look at the future and trends in terms of where the technology is going. But we have to understand it's very hard to predict the future. And we've seen in the history of technology there have been major breakthroughs that no one ever predicted, such as the internet and the web. We're also going to look at technological convergence, the way that technologies combine together to create exciting new paradigms in terms of design. Now, we all recognize that we live in a digital landscape. Everything can be digitized, whether it's text or audio or video, financial data, real-time video. All this can be digitized, and it changes the way we work today. If we look at the history of representation, and I'm looking at the history of architectural design here, what we see is that initially there were no drawings. Everything was done full scale. And that's kind of a different approach from what we take today. But beginning around the 12th and 13th century, we start to see drawings emerge. People start recording their designs, start using those paper illustrations to actually plan the future. We also see the use of models, fairly large models in some cases, that were used to impress the client. Now, these models could cost as much as a small building, but they were used to get the idea across to their clients. Not so much to create the design itself as part of the design process, but more for marketing as we think of it today. Here we have an illustration of Michelangelo presenting his design for the dome of St. Peter's to the reigning Pope. And you can see how impressed everyone is with his model. But clearly this model was not used for designing the cathedral, but was only used to represent it to someone that might have a difficult time understanding how it would eventually look. So in the history of design tools, we're looking at architectural drawings in the Renaissance that architects use today. These architectural design drawings include things like perspective, elevation, section, and plan. All these drawing types were actually mentioned by Vitruvius, a military engineer and architect of the 2nd century. If we look at architectural drawings from the 15th, 16th, 17th century, what we see is that architects are using plan and elevation to actually design their buildings. The interesting thing about plan and elevation is you can take measurements off them and you can scale your drawings. So it becomes a tool for actually managing the construction process. Here we have one example of an elevation study done by Andrea Palladio in his 4 books on architecture, published in 1570. The interesting thing about these drawings is that you can use them to actually monitor the construction process. These drawings become an example for all architects for the next 3 or 4 centuries. In fact, I don't know too many architects today who don't know about Andrea Palladio's treatise. Perspective is another tool that gets used by architects in the design of their buildings. Here we have an illustration by Albrecht Dürer showing you how perspective actually works. And it's a technique that allows you to project onto a 2-dimensional surface a 3-dimensional world. Now, the reason this is so important to us today is because this is the way computers work. If you think about CAD, CAD is actually a 3-dimensional object behind the screen projected onto a 2-dimensional surface. If you think about CAD as nothing more than an extension of perspective, then we really have this history that goes back to the Renaissance when we're working with CAD. Perspective is a very important tool beginning in the 15th century because it allows architects to envision ideal worlds. Here we have just one illustration of an ideal city. And you can understand how this city is structured and organized from this one illustration. The art of perspective was then used to create not only worlds that we might consider living in, but worlds that were fantasies. In the history of scene painting, we can see just one illustration here of how perspective is used to create an illusion of 3-dimensional space. This tool of perspective is even used in the 19th and 20th century by major planners and architects who are trying to show the world how cities could look Here we have an image of Washington, D.C., the plan by Daniel Burnham. And it shows the grand boulevards that we all know about when we go to Washington, D.C. The interesting thing is its point of view. It's a bird's eye view. And it was created without the use of cameras suspended from a balloon or an airplane. Perspective allows us to create views of the world that we can't actually visit or imagine other than from our artificial perspective space. The other thing that's interesting about drawing and painting is that it's a way of conveying to other architects the motifs and the styles that are available for design. This is Thomas Cole's painting, The Architect's Dream. And there you can see the architect. It appears on the pedestal, looking out over time. You can see the ancient Roman, Greek, and Egyptian architecture and that lineage all the way to the present. You also notice over on the other side, medieval architecture, which really doesn't have a place to fit into this lineage. The interesting thing here is that we can use the art of perspective to create these worlds that we can then borrow when we create our own designs. In the history of design, a very recent innovation, photography, has a great deal of impact on designers. We all know that the photography that was used to preserve images of the 1893 Columbian Exposition were critical to the history of architecture. The Beaux-Arts movement, the City Beautiful movement, all get a big push from the art of photography, which shows the city in all of its gleaming white stone. Today, we're probably more attached to video and film than architects were a century ago, and we have to understand that that technology of video and film has a great deal of impact on the way we view our cities. This is just one image from Fritz Lang's Metropolis, a great film that was done in 1923. And if you look at that picture, what you see is New York City. You see New York City of the 1920s, perhaps on steroids, but nonetheless, it is New York City. And that image of the city that Fritz Lang projects in his film is one that we still hold dear to us today. I'm sure many of you know the film Fifth Element. And if you look at the image from Fifth Element, you'll see that reference to Fritz Lang's Metropolis. So now I want to talk about data and image, because when we get into the process of managing data as architects and planners, we have to understand there's a difference between data and image. Image data is basically photographs. Photographs, video, remotely sensed data. That means basically images taken from outer space. We also have data in the form of vector data, which is primarily CAD, computer-aided design, and GIS, geographic information systems. When we're dealing with data, we have vector data and raster data. Vector data is basically the geometry that you learned back in high school and junior high. Raster data are basically the little pixels on the screen on your computer. It's basically an image, nothing more. The computer doesn't see a triangle or a polygon. It just sees basically little pixels. We have to understand the difference between these two if we're going to manage any sort of design process, any sort of design of architecture or buildings or our cities. Images can also be data. If we look at this image from outer space, the colors actually represent elevation. So let's not forget that an image can actually represent data that we see in the world around us. And from that image data, we can actually create vector models. And here we have an illustration of that. Here's the great pyramids of Egypt, represented in a radar image. And from that, we can create an actual model of the pyramids. We can also capture today, using advanced laser technology, three-dimensional images of the world around us. I've been using this technology to preserve images of famous works of architecture in Calgary. Here is just one example. This is an illustration of the kind of data you get from laser scanning. And here you can clearly see we have not only all the detail of the inside, but we can register the external view of this church with the internal view, and we now have a complete model of the building. For urban design and urban planners, we have another form of data collection called LiDAR. And with LiDAR, we can actually capture the three-dimensional envelopes of all the buildings in a city. You can imagine how useful this would be if you're trying to plan future growth. Now, one of the things we're seeing in this world of data collection and processing is that data and images are actually converging. We can now take information about the terrain of our city. We can create a mesh file, which is basically a representation of that. We can then drape images taken from outer space and place them on top, and we now have a good view of how our cities actually look. Part of the reason that we can do this is because there's been advancements in computing. All of you know that computers have gotten much more powerful over the last few years. There's something called Moore's Law, which actually states that computers will double in power every 18 months. And so what we could only dream of doing when I first started teaching over 20 years ago here are now something that you can probably do on the computer at home. One thing to keep in mind when we discuss data versus image is that a picture is worth 1,000 words. But to an engineer, it's not the picture that's important, but it's the data. And I think this is a critical issue that you need to understand if you become an architect or a designer, is that architects and designers, the particular way their building is represented is very critical. To the engineer, just knowing where all the nodes are for his structure is all they need to know in order to calculate the stress and strain. But for the architect, it's how that building is going to look that's critical. So how we manipulate our data is going to be very important to the architects in terms of representing their work. Now, if you come to the University of Calgary, you're going to learn a lot about design, and you're also going to learn about the tools that designers use. Some of these design tools you probably already used, such as Photoshop for manipulating images and editing image files. You'll also learn how to use CAD, computer-aided design. Many of you in high school may have studied AutoCAD in your classroom, but there are other applications as well, things like Vectorworks and ArchiCAD and Revit. The reason I bring up all these applications is because each one's designed for a particular purpose. And depending whether you're an industrial designer or an architect, you will use different types of applications. Now here's just an example of what you can do with CAD. This is a project that I was involved in a number of years ago where we were trying to recreate a temple in Thailand. And here we had just a picture from which, well, we had many, and from that we created a mesh file. Once we created the mesh file, which is basically the geometry, if you want to view it in those terms, just the raw geometry, we could then apply images to the outside of this geometry to make it look photorealistic. I just want to show you one example of student work that was done here at the University of Calgary. This is just a rendering from a computer model that was done in ArchiCAD, which is used by architects to design buildings. And here you can clearly see that what's represented is not lines, it's not cubes and primitives, but actual objects like tables and chairs and windows. Now I want to turn to the use of this technology in planning cities. Many of you will come here and study urban planning at some point. And I think it's important to understand this tradition of using drawing and architectural design techniques to create and project cities as they will look in the future. In the history of planning, most of you are familiar with Paris. Under Haussmann, he basically redesigned Paris to make it look the way it does today. If you walk through Paris today, you'll see as you walk by the facades the result of what we would call today zoning and bylaws represented in the facades. All those facades look the way they do because of the regulations that were imposed on the city. In the late 19th century, with the City Beautiful movement, we see this same kind of tradition of great big plans being projected for cities like Chicago, Washington, D.C., San Francisco, and even Calgary. So now I want to talk about how we can use some of these new computer visualization tools in planning and design. We have something called planning review, where we're actually looking at designs for a new subdivision or perhaps a new part of the downtown core, and we actually have to review what these buildings are going to look like. Traditionally, as planners, we would look at drawings, but today we have new technology, and that new technology can make it very clear to a community what these buildings will look like when they're actually completed. Now, the use of new technology began in the 1970s. Before computers really had a place in design, people would build large models of their cities and then have video cameras with specially adapted lenses that would run through the city on special gantries. They would record the images on video, and they could show the community what their city might look like in the future. Some of this work was done at the University of California, Berkeley, under Donald Appleyard. More recently, in the 1990s, with SGI computing, we had the opportunity to visualize whole cities. And at UCLA, they started building the entire city of Los Angeles so that the community could see not only how it looks today, but what it could look like in the future. And you can imagine as a planner, if you're trying to build support for a new initiative, the opportunity to show the community how their cities are going to look could be very, very important. Now today, we're all familiar with Google Earth and Street View, so you can imagine that we could take this technology and apply it to our own backyard. And in fact, a lot of people are doing that now. In fact, many of you who are watching this video may have created little buildings and placed them in Google Earth and allowed that to be shared with the world. So in terms of the technology today, most of you have on your desktop all the tools you need to be an urban designer. You could certainly use Google Earth. You could download a free copy of SketchUp, and you could create buildings and put them in Google Earth and allow everyone else in the community to see your great plans. And in fact, that's what we can do today. We can show the community the implication of policy that's going to affect the way our cities are going to look. Now, I was involved in a project not that many years ago that looked at this issue of changes in policy and how it's going to affect part of the city of Calgary. And for most planners, what we're looking at are a few issues. We're looking at massing, the size of the buildings. We're looking at setbacks, which means how far back is the building from the street. We're looking at something called FAR, floor area ratio, which is how much area in the building in terms of space as a ratio of the actual plot. We're looking at heights, and we're looking at the general architectural treatment. So I was involved in an exercise a few years ago that dealt with the redesign of a community, one of the communities just outside the core, and they were concerned about the architectural character, but at the same time they acknowledged the need for greater density. New buildings could accommodate more people living there, more retail, more commercial space. And so starting with the drawings that were done by the engineers and planners for the city, we developed a model of that community. And from that model, we could show people what the implications of new zoning might be on their community. Now, zoning dictates the size of the buildings, and in some cases their architectural character, as well as setbacks and heights. So working from the maps that planners traditionally use, such as this one here that shows the land use, and this illustration that shows you building heights, I could create a plan that shows the way this community would look in the future. So the purpose was really to give the community a sense of how their city would look once it was completely built out to the new envelope, to the new zoning envelope. So here is part of the model. And I'm showing you this just to give you an idea of how large the model was. And we built this using computer-aided design technology and modeling technology. And we placed this model inside a virtual world, like a video game. By placing it inside a game engine, we gave the community the opportunity to actually walk through this city and experience it the way they would do every day. The advantage of that is they're viewing it as pedestrians walking through the space. They're not viewing it as architects in plan and elevation. You know, architects have a very good sense of what buildings will actually feel like when they walk around them. But for most people in the community, looking at a plan or an elevation doesn't really carry the same weight. Here we have one computer-generated image of this community in Calgary, and you can see the existing buildings. But once the zoning is in effect and these buildings are replaced, this is the image that you would see in the community. We use this technology to get feedback from our community, to find out what they liked and what they disliked. And that way we could go through a design process, which is an iterative process, to come up with solutions that the community would appreciate. Now, one thing I'd like to point out is I'm showing you single images, but by placing these models inside a virtual environment, I can call up these different scenarios just by hitting a keystroke. I can also walk through the street and kind of imagine what it's going to feel like to actually live there. And in the virtual worlds that I create, the buses go up and down the street, the LRT works, and you get a real sense of how it's actually going to feel. Because our urban environment is not a static environment, but a very dynamic environment. And unless we experience our cities in those terms, we really don't understand the implication of policy on design. So I just want to kind of close my discussion with how information technology and design technology has changed our worldview of cities. And if you look at digital design, it's really kind of changed everything. In the past, companies would create objects and sell them to customers. They might use a wholesaler and a retailer in between to get their products to market. But today we have a whole new supply chain, and something that you're beginning to experience. You can now visit the web, and you can actually decide on how you want to make your jeans. What kind of designs do you want to have on them? And you put that information into a database, which is sent off to the manufacturer. They produce the jeans the way you want them, and they get delivered by FedEx. This is an entirely different way to construct something than we've ever seen in the past. If we look at the history of design in just the last few years, when we've gone from paper to computing, we can see airplanes like the Boeing 777 now being done completely inside the computer. Why is that important? It's important for several reasons. One is it made the design cycle much shorter. It made it possible for them to create an airplane with much better fit. And it made it possible for them to build this airplane in many locations, bring it together and assemble it. We can apply this design technology to many professions. In architecture, we can use this technology to create the structure of a building. We can also use it to the same technology to design a guitar. So I just want to end my presentation to you with a few questions. They have to do with our digital world and how it's going to impact the urban landscape. I want you to just think about how we approach the city today with all the new technology, and how will our cities of the future reflect the new technology that we take for granted every day. Here's a question: will our cities look more and more like video games? When we walk through our worlds, will we expect them to respond to us like a video game? Will we create our cities using this technology as we would create a video game? So will we use simulation to see how people would respond to our world before we actually build it? Or will our cities just look like games but not really be truly interactive? I don't think that's going to happen, because most of you do have smartphones and tablets, and you expect the world to respond to you when you're walking down the street or riding on a bus. You want to get that information about the world around you. So cities are becoming more interactive, and urban planners need to adopt an approach that incorporates the new technology into the design of their communities. So in closing, you've seen a lot today that deals with design and design of buildings and cities, but we also have to think about, once they're created, how will they continue to maintain a contact with all those databases that people are creating? Will we create cities that are, in a sense, interactive worlds? Here's another question: will we create a web space that looks like a city, an interactive environment in itself? Will IT be integrated into all aspects of our life?